So now, to go up a plane, when you're going up a plane like that, you must remember, guys, that there now gravity has come into play. There gravity for the top one, this other one that we had solved earlier, gravity was at right angles with this, so meaning it wasn't working in any way. But then in this case, it is into effect. So what component of the gravity, because you have your weight, which is 8 kg, then you are pushing with 70 Newton, the kinetic friction is 0.2, and still you want to get the acceleration. Guys, if this 70 Newton was downward, the acceleration would be so high because the same gravity, when you're going up, it is opposing. Why? Because it's acting downward. But when you're going down, it's supposed to be added to the applied force. So meaning on its own, even without the applied force, something may slide. So now, what would be the acceleration? So what are the components? On this one, guys, I just want you to master the formulas. I want you to master the formulas. So the force due to gravity, which I'll call Fg, we'll call it the weight, which is mg, sine theta. Which is the theta? The 30 degrees. Why? Because the angle there is equal to the angle there. These angles are corresponding angles. So now, if you have this case, this triangle, it's also a right angle triangle. So the hypotenuse is this very one. So always just know that Fg, which is the force due to gravity, is weight times sine theta, or mg sine theta. When you multiply times the distance there, it becomes equal to the gain in potential energy. So that's the reason why we do that. Then Fk is the normal, which should be there, times mu. So if you remember, guys, mu k. So mu k, you already remember it. But then the normal is equal. They're in the same line with this one. So the normal is equal to W cos theta. So meaning you just multiply mu k times W cos theta. So these two forces, they are the opposing forces. So if someone asks you, how much force should you apply for a constant speed? Then it should be this plus this. But then now we're talking about the acceleration because I'm sure we already know that the 70 can produce an acceleration. So how do you get that acceleration? So what is W sine theta? You say what is 78.4 sine 30, which is actually just half of that. So 78.4 sine 30 39.2. Then how about the friction? It will be 0.2 times 78.4 times cos 30. So this one is simply 13.58 Newton. So these two are the opposing forces, they are the resistive forces here. So to get your net, you say 70 minus 39.2 minus 13.58. This is your net. So that's what you do. So you say 70 minus 39.2 minus 13.58. So you get something like 17.22. Go through, guys, in case I've made an error, but the concepts are the same. Then we'll get the acceleration as F net over m. So it's 17.22 over the mass, which is 8. So divide by 8, which is 2.15 meters per second squared. So remember, if this thing was sliding down, friction would definitely be opposing or the same. Friction is always the opposition. But the gravity will be a supplement. So it means instead of subtracting out this component of the gravity, we have to add it. So I think after this, guys, the rest of the stuff as you are going through, you understand all the Newton laws. I think I've given you 3 concepts that are pertinent and key in solving the Newton laws of motion problems. I'm sure there are those where you have 2 dimensions, where you have something like this. There's nothing tough about them. Where you have maybe a pulley system like that. So always remember that the tension here is what will appear. The weight of this, the tension is uniform in everything. The tension here is what will apply everywhere. So just remember, guys, to be going through your work, go through all those examples that I gave you. Have a good day, take care, and stay safe. Thank you.